It's my proud privilege to introduce to you today Shri Gajanan K. Sadekar, a name which is very, very popular in industry and academia. It's my privilege to share his biodata with you. He is postgraduate in mechanical engineering with specialization in heat and mass transfer and has very illustrious experience of over 40 years. Initially, in his career, he has worked with research and development department at Larsen and Toubro, Mumbai, and was responsible for development and absorption of various technologies. And when companies adopt technologies, it's a very, very important decision. So you can appreciate this point. Subsequently, he has worked in the area of equipment and system business for fertilizers, refineries, petrochemicals, and power plants, including coal gasification in various capacities. He was working as a vice president, product and technology development center and manufacturing technology, process plant and equipment system business with L&T heavy engineering division at Larsen and Toubro. He has wide and illustrious experience in problem solving and failure analysis for various equipment in fertilizer, petrochemical, refinery, and power plants. And it's no surprise, on the basis of the experience that he possesses, that currently he is a very active and busy consultant to many companies in the areas of management and technology. Teaching is his passion, and he has been involved in dealing with various academic institutes from time to time, not only in delivering lecture and technical sessions on career developments and other areas, but also he has worked as a full-time faculty member of the department also. To that I'll come later. He has published more than 20 papers in national and international seminars and conferences before. Most importantly, he has 5 patents to his credit in the area of equipments related to the to heat transfer. And he is member of several professional bodies like Bureau of Indian Standards, Indian Institute of Chemical Engineers, Bureau of Indian Standards Subcommittee for Pressure Vessel Welding and Materials. He is also member of Technology and Energy Expert Committee of ICC, and he is also member of Indian Society of Heat and Mass Transfer. I am sure this biodata can overqualify him to become a successful teacher. He has already papers and patents to his publication, and of course, wild field experience. I must add finally that in addition to this, our association actually began with his appointment as Professor Emeritus at Mechanical Engineering Department in VJTI. He has worked in VJTI as a Professor Emeritus for 1 year, and I must mention, last but not the least, that in a small period of time of 1 year, he became one of the most popular teacher in the department. So with this, brief introduction of Shri Gajanan Sadekar or Professor Gajanan Sadekar, I request him to take over his session. Thank you, sir.
This actually title Professor Naik suggested me was the innovation and creativity in product design. So I'm just thinking in this title, if I look at it, the 2 important things I find I can divide into product design, and for that product design, we require innovation and creativity. So I think we should discuss first, what is really a product design we are talking about, right? And if you see the picture which I showed on the first, this slide is a very interesting, right? Tire of the car, how it has got developed over a period of time. When you look at what is a product is any goods, service, or an idea that can be offered to a market to satisfy a want or need. I have underlined the words market to satisfy a want or need. This means I have an idea for the goods, service, or any idea, product, but it is not satisfying the need of the people, then it has no meaning. Basically, any product is, what is the purpose of the product? 1 minute, and this particular window I can move. Okay. To improve quality of the human life and growth. If you really think over it, actually, when you say really a want or need, what it is, because to improve the quality of the human life, any product which you are developing, the purpose is only one. If any service you are giving, purpose is only one. I want to improve the life and growth of the man's welfare. And that's what is important. You have to think of man's welfare. The product is not just in isolation. And that is what, when this thought comes to mind, then it's altogether different things. Now we have said, if the product, we understand what the product is, this means a good service and idea, and we say it's a product design. So what is really a design means to us? So what is design? Actually, no, just to tell you all, I conducted something similar session, not exactly what presentation I am doing it today for you, but some part of it I did for a lot of people. I might have covered at least not less than maybe more than 3,000-4,000 people, means in different batches. And I used to ask the question to the people, what is design of a product, or what is design? You will get different answers. Generally, I like to do this type of sessions as interactive, but it's not possible on this platform. So what is design? When I ask the question, people ask me tell me many answers. Somebody will say product, idea, developing the something, conceptualization to the product and all that. Yes, I said yes, all the answers are correct. I asked them the question. I said, tell me, for example, would you design your career? Then they say yes. And I said, I'll ask you one question to you. How many designers are there in this audience? So generally what happens in many times when I used to present the thing, the people used to be a mix from the different departments and different things like that. So they will, only few people will raise their hand saying that I'm a designer. So I said, why others, according to me, others also are the designers. So they say, no, may not be. So I said, okay, let us have a look at it further. But we have to define what is design. And then we understand, in designer, when we say it, we have a specific thing in the mind. Somebody is sitting in the design department of the company, or somebody is designing making something, she is doing the, conceptualization of thing, we call it designer. But is it true? We have to think really over it. Now I'll show you some pictures. Look at these 4 pictures here. When you look at these 4 pictures, they give the different thought to the different people. If you really see for example, right hand one corner, there's some building photograph of the architecture. Somebody will think, oh, how this arc has been formed, how this arc has been designed. Somebody will say, no, nice painting, nice colors. So different thoughts will come to the different people. Look at the picture in the down in the left corner, right corner. This is a fashion design. We also call it the design because somebody is wearing the dress. Dress has been designed in a particular fashion, but it's a fashion design. Look at the other picture there. There's some layout of the hotel, or the layout of the showroom. People say, oh, I have to design the hotel. I have to design the showroom. And then look at the engine down. So this is the engine. Somebody says, oh, engine has been designed in a particular fashion. So everything what we are calling all these 4 pictures here, everybody is a design. Everything is a design. They have different purpose. They are different forms, but each one is design. So what is the definition of what is design? I used to ask the people sometimes a question. Just I showed you these 4 pictures, but I will tell you something. I also used to ask the question to the people. I said, look here, when we see the temple, for example, or the mosque, or the church, they have a particular shape. Why they are made in a particular shape? Why the mosque is made in a particular shape? The temple is made in a particular shape. People will give me different answers. They will say, no, because of the weather, and then because of the wind flow, because of the sun's rays. Is it that? So I used to tell them, for me, it's a different story. Actually, for me, is only one reason why they are designed in a particular fashion. Because if I go somewhere and I want to find out the temple, so I did not ask somebody. Looking at the shape of the building, I say, oh, this is a temple, I can go there. Or this is a mosque, I can go there. This is a church. So the reason is that actually has been designed in order to give me the feeling or identify what I want to looking for. So if I have to design what is design, is the design is nothing but the plan for the purpose or the functionality. Plan for the purpose or functionality, and this is true for product, structure, system, or the process in general. So plan for the purpose, when I say, if you apply to our previous pictures, if something is of different products or different systems or different structures, but the form can be different. The plan can be in different form. When the engineer is making, he will make the engineering drawing. Sometimes you tell the people, oh, design the form to collect the data. That is also the design. What do you mean by design? We say sometimes even in our academia, we say we want to design a training program. What it means? I have a purpose because I want to impart some knowledge to the people. For today, for example, this faculty development program, what is that we are trying to do? Professor Naik might have taken a lot of trouble to design the program. She might have asked the first question, what is the purpose of this faculty development program? And then you will say, oh, this is the purpose. Then what is that purpose? How many days I should conduct this program? Who should talk in this program? What should be the content of this program? How they should be arranged? So many things might have gone into the thing. So the plan for the purpose is the design of the program. So one has to understand this is a very, very generic statement, but design is plan for the purpose of the functionality, which may be true for a product, structure, systems. So our pattern with the purpose or functionality. Once this definition comes in mind, then everything associated with that product, structure, system becomes the design. So that's very important for me to, which I'm actually last few years, I'm trying to convey to the people that it is not the only saying drawing something on a sketch or preparing the engineering drawing or doing the calculations is the design. No, design is a plan for achieving that purpose, that functionality, and that is the design. Okay. Am I fast, Professor Naik, or is it okay? I'm very slow.
No, that's okay. That's okay, sir. Please go ahead.
So having seen what is design, how the design really evolution occurs, it's very important to see this picture. If you really look at this picture, it says the man's welfare is a natural resource plus human energy into tools. Right? Now, initially I said, what is the purpose of developing product? Developing product is man's welfare. And how this particular thing is done? We have the natural resources. We use our energy and convert those natural resources into the product. But for that purpose, we require to have the tools to convert that natural resources into desired product. And this means technology is also the product, a tool that we have to understand. And technology development occurs over a period of time. And actually, this law itself has led to the evolution of the development, because if I want to have better and better product, I have to develop the better and better technology. I have to develop the better and better tools, because my human energy is a constant, but that human energy also is used to develop the technology. It's also used to develop the tools. So this is very important to understand. And this, once you understand, then that understands the law of evolution, because the technology, if it is not available for the purpose, I may not be able to use the technology in that product. But today, that technology is not available. Tomorrow, the technology is available, my product will get different form. So let us have a look at this. For example, just look at this picture. Somebody might have seen White Brothers. Somebody has seen those birds flying and thought, I should also fly. So they started probably with a simple thing with a cardboard and burner put into it. And they developed something which was flying. Then slowly over a period of time, the thing got changed. If you look at the picture, what I have shown the series, and today we have A380s, right? Is it that we can laugh at saying that what they made at that time cardboard? No, the technology available, tools available, resources available at that time were of that type. Over a period of time, the way in which technology got developed, resources got developed, the development occurred, and the evolution occurred. So every product's life also starts with something. It changes the form over a period of time for a given functionality. Today, the purpose was to fly. Today also we are flying. But if you look at this picture slide, center I have shown something different, right? They are the fighter planes. Actually, the technology used in the commercial planes and the fighter planes, some part of it is the same, but the purpose is different. So your plan will be different. Your design will be different. Design is nothing but the plan for the purpose. We may use something from the commercial plane technology, but some technologies which are required for the fighter planes, they have different because they have different function to do it. We're going to become the ulta fly. Sometimes the speeds are different, things are different. So depending upon the plan will change. So plan changes, but we can take the technology from one product to the other product and use it depending upon the requirement. Look at the other picture. For example, this I don't think I am even required to explain you, right? These are design evolution taking place. In a car, what happened? And today cars is a models, the people talk about the each one different type of the facilities and things like that. But if the first picture, which is the black and white, would not have come into existence, probably the last picture would not have seen the light of the day. That's very, very important. Over a period of time, development have occurred. Like that, we can give you many. I can give you many examples, right? Look at the next one. This is what actually is close to my heart because this is concerned with our country. If you see the 75, we have SLV, space like launch vehicle. That time we were not having the, we were probably launching in a particular height as well as the product weight and things like that was a constraint. Today, 2000, I shown a picture of 2004, but even today, for example, we have Chandrayaan and Mangalayaan and all those type of things. How the development has occurred over a period of time? Can I say, oh, in 75 we couldn't do that? No, because the technology is available for the purpose, the resources available for the purpose, they're not available in the country. Over a period of time, we develop those resources. The products got developed which are required for the, for example, cryo engines and so many other things. I don't want to get into the details of the list of that. But look at how the development has occurred over a period of time. Today we feel very happy at looking at the Chandrayaan, looking at the Mangalayaan. But it has, if I would not have done something in 75, probably this would not have occurred today. That's really a story about it. Let us look at the next slide. Communication systems. Today, for example, if I ask the question to the people, how many of us write a letter to a letter nowadays? We don't write a letter. We use the WhatsApps. We use so many other means, but later we have forgotten. Postman sometimes becomes the history. I'm not saying everywhere that's possible, but things have changed. So communication, but is it the purpose has changed? The functionality has changed? No, I want to communicate with the people. That's the thing. Only the form of communicating has changed. The means of communicating has changed. Same thing with CAD. We are going to talk today about design, CAD, CAE, competitive design, engineering, etc. So many analysis we talk about. What has really changed? For example, when I used to, just to tell you, when I was in a college, I was not even having the calculator. We used to use the slide rule. I don't know how many people are on this program have seen the slide rule. We used to do the calculation using the slide rule, log tables, and all that type of thing. Logarithmic tables used to be a thing. But purpose was the same. Today we do the calculators or the computation and computer and all the laptops and things like that. Things are changed. Nothing has changed. The function has not changed. What has changed is the means to achieve that function. Okay, it has the advantages. But I should not feel bad saying that it was not there at my time. No, because that time the resources available were of that type and things have changed today. Same thing in the project management softwares. Today, for example, I don't know how many of you know, but at least when I joined my company, we used to do the project scheduling similar way what we get in the today's software. Except that we used to spread the paper on the drawing board, on the board, and we used to draw each activity and connect it by lines, by drawing the lines, and then we used to make the chart. Today, I don't do that. Function is the same today. The format changed because the softwares are available to do the scheduling and so many other project management softwares are available. So just to give you this example, now let us think over in our own life, for example. Each one of us can think, what has changed in my life over the last 10 years? Our activities, how they have changed. For example, Today, most of us, if our mobile is not available with us, we get uncomfortable, right? But when the mobile was not there, still we used to communicate, still we used to do the things, but things are changed. So we have to really think how the evolution has occurred. If you put this particular thought to in our mind, we'll be able to do any development work in a very, very constructive way. Because we say, it is not that I'm not able to do something today, is not my ability, but really what is being, the resources are not available to me. If the resources are available to me, I can do better. And that thought can be coming from this evolution, how it occurs in the design. So really, to summarize what we discussed just now, just give me 2 seconds. Yeah. Just to summarize. No, I wanted to see the time. Okay. Just to summarize, functionality never changes. How the product evolution occurs in the design, or the design which is nothing but the plan for the purpose. The functionality never changes. What changes is the means or the plan to achieve the given functionality. This means product takes different form. Like, for example, the instrument which used to use for ringing the phone at home, that instrument you can't even see. It has gone to the archives. Today the phones are in different forms, but the function is the same. So evolution occurs over a period of time with the availability of resources. Technology is one of the major resources. We have to understand that technology is the major resource. I am saying this because all of us are the people who are involved in the development of the technology. So product design and evolution is a continuous process. And all of us have a role to play in this evolution. That's the reason we are attending this program. That's the reason we are involved into this. Our engineering faculty itself is nothing but we are very much a catalyst to this evolution. We have to really take this message. The technology is one of the major resources, and the product design and evolution is a continuous process. For example, many of us, for example, used to, I remember in my, when I did my MTech, for example, post-graduation IIT, so searching the literature used to be a very, very big task. Because I used to go to library, then I'll find some journals, and then I'll go page by page to find out which paper is useful and all those things. Today, a click of button, I can get the complete literature survey for myself. So things have changed. Evolution has occurred. It has its own advantage, but we must be able to take the advantage of that in development of the products. Okay, let us see the little further now. So this is what the things are all together. If you really see what we have discussed now, the science, technology, from science, technology is the use of the application of scientific knowledge for specific goal or purpose. Which the purpose? Satisfying the society's need. So this picture actually shows that it's a back and forth. So since science contributes to technology, technology is required for the society. Similarly, society will demand something, so scientific development will occur. That scientific development will get converted into technology. So this is a cycle actually. So what is really, having seen, we have seen what is design. Design is actually a plan for the purpose or the pattern with a purpose. Then what is design thinking? So design thinking is a process for preparation of the practical and creative plan to achieve the desired purpose. If you really look at this slide, I have given a different color to some words. It says practical and creative plan. So anything plan which I make, means whichever design I make, you can design the plan for the purpose. If that is not practical, if I'm not able to implement, then that plan has no meaning. If I make some design, and if that design is not going to get converted into the physical form or the practical aspect of it, if it is lacking, then that plan or the design has no meaning. Similarly, it should be creative, because if it is not creative, it will not give me the energy to do something differently. Creative doesn't mean, for example, I must feel something that I have contributed, I added the value to it. For me, the creativity is nothing but adding the value to what you are doing. If you are not, then you are not creative. If you are not adding the value, then we always say no, because it's my routine work. Why I feel the routine work? Because I feel I'm not adding the value. So creativeness is nothing but adding the value to it something. Okay, to achieve the desired purpose. So this design thinking, one has to keep in mind. I have to develop the plan which is a practical and creative, and it satisfies my purpose. Having seen this design thinking, so what are the steps involved in the process of design thinking? So if you really look at these steps I am written here, there are 7 steps: define, research, ideate, prototype, choose, implement, and lean and learn. What we are going to do is each one of these we'll discuss in detail. So let us go to the define. If you ask me, in these 7 steps, the first step, define, is the most important for me, because decide what is the purpose of the functionality you are trying to achieve. Many times we listen saying the well-defined thing solves the any problem. 50% is solved if you define properly. What it means? Because defining the purpose, defining the functionality, defining our requirements properly is very, very important. Because the further plan, how it's going to be, depends upon how well you are defined your requirement. If your requirement is not properly defined, your plan will not be appropriate. And that's why it is very important. And while defining that particular plan, we must identify end users. Who is the use? What is the purpose of it? Who need it? What is the need of that person? Who are you going to use it? For today, for example, anything what you do depends upon different things. Just to give a lighter example, in a fashion designer, they design something which many of us will feel, oh, why they are designing like this? But they have different end users. So they have identified their end users. Each one is the different category of the people they have done, and they say, I want to design for these people, this type of thing, this general people, this type of thing. So each one has to identify the end users and prioritize this project in terms of time schedule. Many times in our context, I feel we do the activity, but we are very much lacking. So see, for example, many times what happens when I do want to do something, I want to do the perfection. Many times perfection may not be possible, and because of the perfection requirement, my time schedule goes heavy. Many times we start our project at the development of something and it takes 5 years, 6 years. Why? Because we have not defined our things, saying that I will finish this part of it, I will have these are the requirement of mine, so I need not worry too much about it, but I'll complete in time. So time schedule is very, very important and determine what will make this project successful. Actually, many times we think, why should I think of it? No, but important. We have to identify the critical thing. What is that critical to the functionality of this project which will make this project successful or this product successful? Because if you have no idea of what will make successful, then your plan will not be richer. So let us go to the next one. So I don't want to elaborate this too much because I'm sure all of you must be familiar with this part of it. Now look, next is the research. So what is really research? Okay. So though I have written, now I'm showing you the slide. I generally don't show the slide when I'm talking in the audience with the small groups, because I want to ask the question. So I ask them, what is the research? So many people would say research means doing some experiments and doing something, etc., etc. So one day, actually, just to give you an example, I was giving the lecture in my shop. One of the shop in charge called me, a manager, and told me, sir, can you give a lecture to my supervisors in a shop? And actually I was delivering something like same lecture, some part of this lecture there. So when I came to this slide, I just asked them, I said, can you tell me, do you do the research? So my shop manager was looking at me very angrily. Our shop people, supervisors, and you're asking whether they do the research. And to his surprise, 3 people raised the hand saying that we do the research. So I asked them, what research you do? They say, sir, when we get any order and we have to fabricate on our shop floor, we go and find out whether something same or the similar jobs have been made in the past and what obstacles we have faced. What problems came at that time? Fantastic. I said, excellent. And if you read in my slide, that's the first sentence. It says, I have a purpose. I want to make a plan for it. So I have to find out either same or similar thing has been made in the past, what obstacles came in that. And if I know those obstacles, I can do the study of those obstacles, why those obstacles came. I can do the research on it. I may do the experiments, I may not do the experiments. That's a different story altogether. Because that is not the purpose, is to find out what are the lacking in that plan, which has not made it so successful, so that I can make my plan richer. And that is the research for me. Then collect examples or attempts to achieve the similar purpose. These are all other things. Finding those obstacles. And what we do the literature survey in our thesis, for example. What I find out, if I'm going to do the study on this particular research on this particular topic, what has happened in the past? So I know what exactly has gone wrong, or what I should improve and things like that. So that is the research for me. So talk to the end users, you will get many ideas. If somebody is going to use it, he will give you. That is the research. That's how people do the market research, market survey. Why market survey? Market survey is a part of the research. Okay, so this is just to give you a little example of it. Once you define your product properly, you have done the research. Now, next thing, just to little bit your slide. If you really look at the research, why research? Research is what? Basic research, applied research, application development, and quality of life. Anything what you do, the purpose is only one: to improve the quality of the life, man's welfare, and there's no second thought about it. Okay, and really speaking, when you think in this particular thing, when man requires something, man welfare requires something, you think of technology, advancement of technology, developing those applications from the technology. If something is not available, you do the basic research. So this is how cycle ends. So let us go to the next step, ideation. This is a very, very important, because we are defined now. We have defined what is our requirement. We have done the research on it. Now we have to develop ideas. So idea generation is very, very important function, because that is how your plan going to take place. Your plan or the design going to occur based on the idea generation. So identify the need and motivation of the end users, which we have already done in the definition part of it. Generate as many ideas as possible to serve the identified purpose and needs. Because developing the many more ideas, looking at this, do the brainstorming and things like that. That is, I don't want to get into detail of how to do the idea generation and all that. All of you, I'm sure you must be doing that. But most important, only one thing I tell you: anytime ideas comes to your mind, don't try to strike out that idea immediately, saying that, oh, nahi hoga, this will not possible. Don't say that, because the reason is, if you start doing that, the doors for idea generation gets closed. So put down your ideas, whatever comes to your mind, as many as possible, and then do the evaluation at the end of generation of the idea. Then start evaluation of it. But many of the things, what happens in our, generally I have seen our product development, etc. As soon as you start doing something, somebody says something, oh, you can, why can't you try this idea? No, it will not occur. We are very, very judgmental on many occasions. So I think you should really, what you do is note down those ideas, think over it, because no idea is really a bad idea. You have to have this in mind. Every idea has its own pluses and minuses, and we require the evaluation. Once you do the idea generation, develop your ideas, the next step comes to what? The prototype. So actually, I asked the question to the people. I said, can you tell me, have you done a prototype? Generally in the audience, many times, only 2 people will raise their hands. Oh, during my MTech or BTech project, no, I was supposed to make some model. So most of the people have the idea of making the prototype, means making some model or making some physical thing for prototyping. For me, it's a little different. Actually, I was asking that question to I was conducting something similar lecture for the design engineers. So I asked them, do you do the prototype? Design engineers, when I say everybody is a designer, however, they were working in the design department of the company. So I asked them, do you do the prototyping? They said, no, sir, we have no chance to do the prototyping. So I said, no, at least my feeling is you do the prototyping every day. Then say, oh, no, sir. So I said, how many of you make the Excel sheet? When you make the Excel sheet and put the formula in the top, first, before making your complete Excel sheet applying, first you do the physical calculations, based on that formula, and check whether the result is coming in a table, first line is okay or not, and then you apply for all other data. So that is a prototyping. So what is the definition of the prototyping? For me, the definition of the prototyping is validation of the plan for the purpose. I have made the plan for my purpose. That's the design for my purpose. And whether that plan is implementable or not, I want to verify, validate. And that validating is nothing but the prototyping. So if you have this idea in mind, then prototyping changes. For example, many times it is not, suppose you are designing the big machine or something like that. It is not necessary the prototyping should be in a full scale, everything. But I can say in this particular machine, this part I have used somewhere and it has worked. So I did not test it. I did not do the prototyping of it. But some of the part of it, or some circuit part of it, is not tested in the past. So I want to do the prototyping of it. Just validate that part of it. So prototyping can be done in full, prototyping can be done in a part. So prototyping doesn't mean that everything should be made to the scale and then run it. Not necessary. You can do in a part, but basically a validation. Many times, for example, we do the prototyping also. Suppose if, for example, research and prototyping are actually connected. Many times I want to go on a holiday somewhere. So what I do, I go and ask somebody, where you went? Okay, I want to go to that place. What are the problems were coming? So I do the research part of it. And then I say, you have any problems in doing this particular thing? You stayed in this particular thing, stayed in that part. So I start doing the prototyping of it. I validate whatever thing is in my mind. So prototyping is nothing but validation of the plan for the purpose before implementation in full. Before I implement full, I must know that my plan will work. And that's the prototyping is all about. So let us go to the next thing. I go a little fast now because we are already consumed half an hour. So now once you do the prototyping, because we are defined, we have done the research, we have idea generation, we have done the prototyping. Now choose the best idea out of it, keeping purpose in mind. Keep the purpose in mind and the idea. Remember the resources available to you, whether it's a practical to thing, evaluate ideas based on the prototype and select the powerful idea. And that's, I'm sure this particular thing, all of us must be doing it, but this is to just to refresh. I have put these points here and then implement, assign the task, execute, because implementation many times becomes little, people say feel boring, but no, I think implementation, once, if you do your 4 steps properly, implementation goes anyway. And after implementation, the next most important thing for me is a learning. What happened during my implementation, whether that implementation has achieved my purpose, and gather the feedback from the users. Somebody is using that product, find out what has gone wrong, find out various problems which are occurred, and how can I improve. Because, and most important for me is to document all that data. But what happens to many of us is when we get some problems, we don't document them. So what happens next time somebody is making the plan, she will not know what problems had come. Because we only focus on the end result. Many times we lose our focus what happened in the process. Because, whereas for me, more than the end result, what happened in the process is very important. Because that will be a learning for future, and that will give us impetus to develop the proper plans for our future requirements. Okay. So we have seen these 7 steps. So now, having seen the 7 steps, actually, what is actually a process of design? It's very, we have seen all 7 steps. Now, what is actually a process of design? The actual process of design, see, anything which you want to do, any purpose you want to satisfy, we want to make the plan, there will be some constraints, right? And those constraints, actually, one can classify into negotiable and non-negotiable. Now, in a true, when I say negotiable and non-negotiable, it is a true English meaning of negotiable and non-negotiable. Okay, non-negotiable. I'll give you an example for this. Let us think. I want to design the chair on which I am sitting now, for example, or you are sitting, must be in your place. You want to design that chair. You want to prepare the plan for design of the chair. What do you think is a non-negotiable constraint? So many people, when I ask this question to the, when conducting this lecture, am I audible? Okay.
Yes, sir, you are audible. No problem.
Yeah. So when I ask this question, whether are you non-negotiable, people answer What is the thing non-negotiable in design of a chair? They give the answers like the size of the seat. Then they will say whether it is having a comfortable thing or not. What is the material of the chair? So many things answers comes. So I generally tell them size of the, when somebody says size of the thing, I said, have you traveled in Mumbai? Or whether on a train, when people, even if your seat is not available, you take the fifth seat. Whether you don't mind having a small seat to sit at that time because the legs are paining. Or suppose you are standing on a bus stop and a bus has not come for 1 hour, you actually sit on the rod which is there on the bus stand. You don't feel uncomfortable because that's the need of the hour. So that is not, that this means is a negotiable. It is not a non-negotiable. What is really a non-negotiable? So for me, the chair, actually, if I sit on the chair, legs of the chair should not break. It should not fall down. So design of those legs, or the load carrying capacity of that legs is a non-negotiable. All other things are negotiable. For example, take another example. When you travel in a high-rise building where the lift is there, you might have seen it is written there somewhere, saying that for 8 people only, for 16 people only, for 12 people only. What is that actually? What is that somebody is conveying to you? Somebody is conveying to you because my plan or my design for this purpose has been carried out considering the load of the 12 people. So all components in this particular thing are designed to satisfy load of the 12 people. So it is non-negotiable. But all other things can be negotiable. For example, chair. Material can be negotiable. Whether it should have a back seat or not is negotiable. Whether it should have handles of what type, whether it should have carving or not, all they are negotiable. Depend, only one parameter can come in the cost, but we are not talking about, we are talking about technical part of it. Then a cost is also can be another constraint which can come. But so we have to identify anything we are doing in our activity. We should identify negotiable and non-negotiable activities and constraints and classify them. So what is really, now we have seen the process of design involves the management of constraints. So let us look further little. What is really an actual process of design? So actual process of design is nothing but design process leads to manipulating design variables to satisfy non-negotiable constraints and optimizing negotiable constraints. Actually, what it means really is never optimize non-negotiable constraints. You can really manipulate little. For example, just now I gave the example of the chair. No, same chair. I can say I've designed this chair for the people less than 60 kg and another chair for the people more than 60 kg. Possible to do that. You can manipulate little variable and then do the different plans for two different, because now we divided the purpose into 2 categories. So you can manipulate little, but you cannot negotiate. It's a non-negotiable. The load carrying capacity of the chair legs is a non-negotiable. So what anytime you do the design or develop your plan, find out non-negotiable constraints. Don't try to negotiate. Don't try to optimize them. Only optimize negotiable constraints. For example, you might have seen it in a process plan, heat exchangers. Many times it is written there. You know, there is a tip sheet in a heat exchanger. Tip sheet. So tip sheet is facing both sides pressure, cell side and the tip side, right? And basically it will be designed. Tip sheet is generally designed for the full highest pressure either on the cell side or the tip side. But many times, because the fluids or pressures are so high, that people design the tip sheet for the differential pressure. This means both sides fluids, what is the difference between the pressure, and people design the tip sheet for the differential pressure. And they write on the equipment at the outside. The equipment has been equipment has been designed for differential pressure. You know why? By chance also, you should not put only one fluid on one side. You should put the both fluids simultaneously, because otherwise the equipment will not work. So there's non-negotiable constraint, and that's why it is written on this particular thing. You know, these are the, like for example, very lighter side example. When somebody in a box, somebody puts the glass, glass made equipment, we write outside. It's having the glass inside, so handle with the care. What is actually that? You are saying is a non-negotiable constraint. Please take care of it. So non-negotiable constraints should not be optimized. Okay, so this is actually the process of design. So let us go a little further and say, just to summarize, what we have seen till now. The design is a plan for the purpose. Evolution occurs over a period of time with the resource availability. Technology is also very, very important resource. Design thinking is nothing but 7 steps: define, research, ideate, prototype, choose, implement, and learn. And the actual process of design is nothing but management of constraints, negotiable and non-negotiable. The concept of process of design is applicable to every activity we perform during the development, and it encompasses all aspects from concept to realization of the end product. You know why this? If you really look at this statement, the concept of process of design is applicable to every activity we perform. So, for example, I am developing the plan. For my purpose. I did not give me 1 second now. Yeah. So when I'm developing my plan, for example, it encompasses all aspects. I say this means my product, how I'm going to, what materials I'm going to use, how I'm going to manufacture it. That also will come to the picture. How I'm going to test it. So all aspects of it comes to this, and each activity is nothing but the design, because it requires the plan. For example, I want to make a test equipment. I must know how I'm going to testing it. What equipment I require for testing. I have to, that also has to go through all those 7 steps. You know, so every activity goes through these 7 steps, and so that my purpose is met. So just to conclude, just to summarize this, whatever we have discussed till now is, we have an avid designer within us. Very avid designer is within us, and let us free the designer within in order to make the product design richer and richer. Now let us look, having seen this, how to make really a designer, empower the designer. I'm a designer, I want to free the designer within, so I have to empower myself. So how I'm going to empower myself? So empowering the designer within us. If you read the first sentence itself, it says effectiveness, efficiency, and reliability of the end product and system is of utmost importance and should be the main goal of the product development. If I'm developing the product, it is for some purpose, to satisfy the need of the people, to improve the man's welfare. This means it must have the proper effectiveness, it must have the efficiency, and it must be a reliable product. When I go and buy something from the shop, for example, what I look for, I say how reliable this product is, how efficient this product is. What is, whether it will satisfy, effectiveness is nothing but whether it will satisfy my purpose or not. It's effective for my purpose. So all the, and that for any product development, this is the main goal. And reliability, all this reliability will come from where? Depends on the design, plan, how reach my plan I'm making for that purpose is depends upon, it will determine all these 3 parameters. And the richness of design is based on knowledge, research, and experience. Right? Richness in design will come from knowledge, research, how well you research, and what is your experience based on that product. And knowledge and experience gets further enhanced with the learning and its analysis while implementation, and provides impetus to innovate. For example, as I said some time back, important is not the end result alone, the process through which you have gone. In that process, what problems you have faced, that experience and learning coming from that process, you should analyze it. What has gone wrong, what has gone well, what has not gone well. And once you have that analysis for the implementation, it will give you different ideas, because you say something has gone wrong here, so I should develop something. So actually, when people say I want to do the innovation, the best thing is only thing, every time start analyzing the learning of your implementation, and that will give you the ideas for innovating. Ideas for innovations will come from the usage of the, when you use the product, think over it. When you use the product, you say, oh, ye barabar nahi hai. No, for example, if you are using the product and you find the problem, little bit think, what is that really not satisfying me? What is that going wrong in this particular thing? What might have happened? And then that will give you the idea for a development, idea for innovation. Okay, and creativity and innovation plays important role in the product design, development, the products. That is very important to understand that the creativity and innovation when you are talking about, because that's what we, in our title we had two words, creativity and innovation. So actually innovation and creativity will come into existence once we do our basic research properly. We have the knowledge, we have the experience, learning from the experience, and that will make us, our creativity will flourish. Okay. So having seen that, let us focus. We are talking about three aspects, right? Effectiveness, efficiency, and reliability. So let us talk at the reliability. If you look at the product life, these are actually the product life cycle which I have drawn here. These are from the technology point of view. The product life cycle in the market point of view can be a reverse of this. This is a bathtub curve for which is generally talk about. If you really look at the first one is the infant mortality. Failure rate will be maximum infant mortality, useful life of the equipment product, and then slowly the product will wear out, function will maybe happen something. In process, actually, what are the reasons for that? Result of a gross defect, infant mortality. Actually, this is a true curve for even for the all of us human beings also. Normal wear, tear, and the result of aging. Look at the top what I have done there. The first two, that is the infant mortality and useful life, depends upon the mostly how well you have made your plan, that is a design, and manufacturing part of it. Because and the last two are how well we are operating. For example, I buy some machine and I don't operate it properly, also can give the problems. How well I maintained it. So if you really see overlapping area of these two is nothing but where operating useful life. And our whole purpose, our product should last as much as possible. Useful life should be more. So we must understand. So if you really look at it, the next slide, let us before that, let us go to the gross defects, why they will occur. Why the gross defects will occur? Because selection of inappropriate material, inadequate design. This means our plan is not really properly done. I have not used the proper design methods. I have not used proper design tools. Inadequate testing. For example, while manufacturing of the equipment product, I have not identified the defects. I have not tested it properly. Something remains unidentified. That can give the problem. Or I am not starting the product the way in which I am supposed to use it initially, so it can have infant mortality. And really this particular thing is a responsibility of the product development, which comes in the all your steps which are initial period of the product development. Having seen that, so actually product reliability depends upon all four factors: the basic configuration and the design, that the plan for the purpose, how well you are manufacturing that product, how well you are operating, and how well you are maintaining. So all these four factors are responsible for the reliability of the product. Just to summarize what is exactly these critical factors are, like basic configuration, when you talk about selection of materials, normal and abnormal operating and design conditions. These are very, very important things. Specifically, if you are designing the equipment for the process plants or for some, say, power plants, or in that way, it is for anything. Whether you are doing you are designing some machines which are in a machine shop, whether what are the abnormal operating conditions can occur, what type of loading can occur in abnormal conditions. If I don't know that, I will not be able to do the plan for the purpose properly. What design methodologies I am using, whether design methodologies are really they are suitable for this purpose, very important. So these are some of the related to that. Then manufacturing processes. Which manufacturing process I am utilizing? Am I using the proper manufacturing process? What type of quality control I am using? What type of final testing of the product I am doing? And operational maintenance. Really, reliability consists of everything. It is not only, we always, what happens is most of the designers in the college or myself, we think, oh, my design should be good. The design comprises of everything of the product life cycle. If I don't know the product life cycle, I don't know how it's going to operate, how it's going to maintain, then it will not serve the purpose. Okay. So just to conclude that this section, for example, if you treat these four aspects independently, your product likely to fail. But if you want a reliable product, you have to successfully integrate all these factors into our plan. When I am making the plan for my purpose, it should incorporate all aspects of design, configuration, manufacturing, operation, and maintenance. I must know how this thing going to operate, how oh, this is going to maintain. All these aspects will come, then there will be a reliable product will be there. So having seen this reliable product, now let us go a little further. What is really then innovation? Because see, each one of this particular thing requires little bit thinking, creativity, methods to be developed. Because we have seen the product development is an evolution occurs over a period of time by developing some means. And developing new means is nothing but innovating those means. Right? So let us read the little bit part of this, the creative process and innovation. Many times what happens to us, all of us, is creativity and innovation we treat separately. We say they are more like the same, but actually they are not really same. Whereas creativity is the ability. It is not the activity. Creativity is the ability. And innovation is the activity. There is a difference between the two. The creativity is the ability and innovation is the activity. Innovation is the process of doing something. Through creativity, you are not doing something. Creativity is your ability available in you. It's the actually power of yourself. Creativity is your own power. And innovation is actually you are converting that power into the developing the idea, that is things, that is the innovation. So ideas have a little value until they are converted into new products. Your ideas, very good ideas, but I'm not making the products or the services or the processes, I'm not converting it. The innovation idea has no meaning. Innovation, therefore, is the transformation of the creative ideas into useful application. A very important thing here, creativity is a prerequisite to the innovation. Because it's the ability, if I'm not having that ability with me, I'll not be able to innovate. So creativity is a prerequisite to the ability, to the innovation. Action by itself has no meaning. It is a little value to simplify, do things without having inspiration and direction. Ideas usually evolve through a creative process whereby imaginative people germinate ideas, nurture them, and develop them successfully. Okay. So basically, if you look at this overall thing, what is the really creative process? Creative process is the thinking, the ideas, and converting them into a product, and that is the innovation part of it. Okay, so those said they're imaginative people, but I don't agree on it. It is not the imaginative alone. If you do your proper study of those 7 steps, you will become the good innovator. Because if you each of the stage, if you start looking at it constructively and find out what is going wrong, so during the implementation, what is the really going to be the problem, then you will be able to innovate. So identification of the problems is actually key to the doing the innovation. Having seen that, many times we little get confused between the invention and innovation. So what is invention? Invention is the creative of something new. And what that results into the knowledge. Invention results into the knowledge, whereas the innovation results into a product, service, or the process. Basically, innovation is using the invention, that's the knowledge it is using, in order to transfer that knowledge and ideas using the resources into useful applications, and that is the innovation. So actually, invention occurs, the knowledge gets generated, then you convert that knowledge into using the resources into the product or service, and that is the innovation. So this is very important to understand, I feel, about it. Many times you get bogged down, oh, I'm not inventing. Don't worry about it. Available knowledge is enough in order to make the innovation. Okay. Having seen that, let us see what is the creative process model. So what is the really creative process involves? Creative process involves 5 stages: recognition, rationalization, fantasizing, realization, and validation. So you have generated the idea. You must see the stage of new. As I said some time back, by need I have to understand, purpose I have to understand for which I am doing. Automatically your ideas will get generated, and that is the recognition. Recognition word is used very carefully in a creative process, because recognition of what? Recognition of the need. Recognition of the need is very important. If I am not recognize the need, I will not be able to generate the idea. If I am not able to define my need properly, if I am not able to define my purpose properly, I will not be able to develop the idea. And that's why it's called as the recognition. And once the recognition will happen, then I have to preparation for that. The Rationalization. So ideas has to be what we talk about, a little bit about prototyping, and the choosing the ideas comes into the part of rationalization. And then incubation, subconscious assimilation of information, fantasizing. You think over it to develop that idea, and then realization of the idea, and finally validation of the idea. Anything which the application, if I don't test it, if I don't validate, is no problem. So that's what we talk about prototyping. Okay. So now this is something I have put this slide actually purposely, because this slide is a mixture between the technology and the business. I say innovation is a growth tool. Innovation is the specific instrument for entrepreneurship. Actually, every person, sometimes we feel I'm working in academia, I'm not an entrepreneur. According to me, I don't agree on that. But if you really look at what is the entrepreneurship, what is your product of the faculty, or what is the product of the faculty? You are preparing the people to develop the products, develop the services. So you are actually doing your product is very, 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 very important and very noble, because and you must think that entrepreneurial characteristics are required in the teacher, in the faculty, because you are developing the product. Who is developing the? You are developing the product. Which is going to develop the product and services to improve the life of the people. So that's what it is. Actually, I written this particular slide only for that purpose. It is the act that endows resources with a new capacity to create a wealth, creating the wealth. For example, how the academia can create the wealth. Academia can create the wealth by developing the people who are capable of developing the new product and services which will create the further wealth. So actually, if you see, there's a linkage between the academia and the industry. Whatever changes the wealth producing potential of already existing resources constitutes the innovation. I think it's a self-explanatory. Innovation does not have to be technical. Don't worry about this, but we are doing the technical innovation. So, but it can be economical. Finally, it has a social impact. And innovation can be defined as the changing the yield of the resources. This is very important for me. Actually, what innovation happens? My resources, I'm able to use it optimally. Whatever information, that's the reason when you say evolution occurs, because many times we say we should innovate, but for innovation, you also require the resources. And then one can think of generating the resources from the available resources. This statement is a little vague why I'm making. One can generate the resources from the available resources means sometimes we have fixed ideas in the mind, saying that, oh, I require this resource. I'm not, many times people will tell you, oh, हमारे पास ना ये software नहीं है. We are not having this software. Don't worry about the software is not available. Find out the alternative to that software. Find out what I can do through that software. If the software is not available, what else can I do? So generating the resources from the available resources, not available resources, is what innovation is all about. Okay, so that is what. And if you understand, if you think like an entrepreneur, if you think like this particular entrepreneur, I am the owner of this particular activity, then innovation will occur at a very fast run. That can be a growth tool, because you are generating the people who are actually going to generate the products to improve the welfare of the people. Now, having seen this, let us look at what is the development process. So whatever we have talked here is more or less like a summary written here. Look at the idea have a value. It must be proven useful to the marketplace. We said that any idea, if it is not convertible into a product, useful to nothing, for a purpose, some purpose, then there is no point. So analytical planning, organizing resources, implementation, and commercial application. I listed a lot of points there. For example, if you see the analytical planning, to identify product design, market strategy, financial need. So when you say analytical planning involves product design, plan for that purpose. As soon as I say that, now for example, somebody will say, yes, but this product should be serving the purpose, but is it at the marketplace? Because have I identified proper marketplace for it? And then anything want to develop, you require the financial need. So that all planning goes into the innovation process. Innovation development is not just like that. Because the reason we analyze the innovation, we are thinking from the narrow point of developing some in our institute. No, Finally, you have to think that this particular product, what I'm developing, will be will go into the marketplace, will be improving the life of the people. People will use it, and for that purpose, when I'm developing, it must satisfy every aspect of it. And that's why all financial need and all that type of thing. Suppose, for example, I'm developing the product, and I say my product is very, very expensive. It will not get sold in the marketplace. What is the use? And also to develop that particular thing, you require the financial need. Managing resources, materials, technology, resources, implementation of that. So product design, manufacturing services, and commercial application. So we will not worry about what is written at the bottom much, because that is from the industry point of view. But for even in academia, all these first top 4 points, analytical planning, organizing resources, implementation, and commercial application of that is very, very important when you are developing some product in the organization. You are developing your own people. So, means like students, for example, they also require to go through this particular stage, because many of the colleges, for example, they say our people get 100% job. What we are really looking at it? When I say our all people this year got 90% of the people got job, that's what you do the advertising, right? What it means, you are actually saying that the product which you have produced has a commercial value. This may be a lighter side, but just to explain the concept of it. Okay. Now, having seen the innovation process, we have seen the reliable product which is required, which empowers us to do the better plan. Most important part of the innovation is actually the value improvement. What is that innovation for? Innovation is only for one purpose. I want to improve the value. I want to add the value and improve the value of the product. So let us understand what is the value of the product. Value improving practices. I have written the title purposely. Under innovation, I have taken the topic value improving practices. And I have written the value equation as V equal to F by C, where V is the value of from the owner side. Look at what is written there. V is value from the owner side, and equal to function divided by the cost. F is a function, C is a cost. So value is function divided by the cost. And what is value? Value from the owner side. For example, I want to go and buy the mobile. I say, "This mobile na itna value nahi hai." What we are talking about? You say, what is my functional requirement? For that and the price which I am paying for it, they are not appropriate. So value from the owner side. You know, on this slide, I have shown some tomato. Are you wondering why I have shown the tomatoes there? I have shown some baskets full of tomatoes. You know, whenever I explain this value equation, I generally give an example. I said that you have to improve the value. If you really want to learn how to improve the value, you go along with your wife or mother or sister to market to buy tomatoes. Look at this basket. When you go to the market, sabji wala, he will have 2 or 3 different baskets with the different tomatoes. In one basket, there will be big tomatoes which are very hard and very nice color and all that. The second middle basket will have a little bit, little smaller size. They are not so good, little bit. Third one will have small and they are little soft because they have probably time has gone and they have become little soft. Now, when this lady goes and want to buy, she asks the rates of this particular thing. The fellow says, what is the rate? He says 100 rupees, 80 rupees and 60 rupees. What do you think? Which one she will buy? 100 rupees wala, 80 rupees wala or 60 rupees wala? Generally, people think, oh, they will say, no, middle wala lenge 80. No. What she will say, today, somebody going to come to my house for dinner and I want to make the salad. So I require the very, very hard and big tomatoes. So the salad looks attractive. So she will not worry about the 100 rupees. She will say, give me this. But she says, no, today I'm going to make this soup in the evening. Then she will, which one she will buy? She will say, how it makes a difference? They are soft. Anyway, I have to squeeze them and make the soup. So she will buy the 60 rupees wala. So in her mind, she has calculated the value. Function divided by the cost. What is the function I'm utilizing for and what is the cost I'm paying for it? So value is looks little silly example probably, but it tells you what is really a value for the person and value from the owner's eyes is all about. Okay, so if you there are various practices to improve the value. There are many practices for improving the value. Some of them I have listed here. Anyway, value can be increased because we have seen value is a function by the cost. So either you can improve the function or you can reduce the cost of the product. So either of the two you can try attempting in. And most of the techniques available down what I have written here, so one of the things of this particular thing, either they improve the function or they reduce the cost of the thing. Like for example, lean, you might have heard about lean manufacturing, right? You reduce the wastage. When I reduce the wastage, automatically the functional cost comes down on the product. So that value improves. So Six Sigma, quality improves. Quality of the product will improve. Design of manufacturing and assembly. So for example, if I'm doing this particular thing, again, cost will come down. You have to see improve the function, cost. So each one of this has a different purpose. But all the techniques, actually, one should not get bogged down by the techniques for value improving processes. You can use anything which you feel suitable for your purpose. But finally, one thing is there, F and C, V equal to F and C has to be kept in mind all the time. Whether that is helping me to do that part of, to improve the value. And then there are value engineering and all those type of things. So what I am going to do, I will not be able to discuss all these things, value improvement practices, but I have two things which are close to my heart. I'm going to talk about a little bit about it. The first is a TRIZ. So actually, I don't know how many of you have heard about TRIZ. It's a theory of, it's not really a full form, but theory of inventive problem solving. Actually, this theory has been developed by the Russian G. Altshuler, and he was actually a patent reviewer in the Russian Naval Patent Office. Okay, in 1946, if I remember, and he was reviewing various patents, of different patents used to come to him for review, and he was reviewing that patents. He has reviewed something like 2,000 patents, and when he was doing that, he found that most of the patents have some inventive problem is being solved. And actually notice every inventive problem have the conflicting requirements. Because sometimes something increase, something gets reduces. That is you find lunch is not free, no? So if anything you want to improve something will come down. So he found there are conflicting requirements, and he called that as a contradictions. And he found when he studied all these particular patents, he found something that is a common in this particular thing. Just to give you an example first, and then we will come to what he did. Look at these 4 problems. Airplane tires wear fast. Second problem is, in our semester education system, students are not able to retain the knowledge. In third is, in a paint shops, loss of paint occurs in mixing well, having an agitator. Oh, there's some mistake in that now. Okay, agitator. And last one is data loss in high-speed digital data transmission system. Okay. If you look at these 4 problems, I generally ask now, I have written already there, but I generally ask the people, I tell these 4 problems, are they same or they are different? So most of the people they are different. You know why? Because they are from different fields. One is air industry mein se hai. Second problem is from education. Third problem is from paint shop. Fourth problem is from the IT, digital and data transmission. But if you really look at this problem, they're looking different because they are different. But look at the effect of this particular thing. For example, all these 4 problems, let us take and understand what is the cause and effect. In this case, cause is what? Effect is what? The loss of material. In all the 4 problems, you notice there is a loss of material. And what is the cause for it? The speed. If the airplane lands just like that and comes at a rest after stopping immediately on the ground, I may not wear. Because it has to moving at that speed on the ground, the wear occurs fast. So speed is the cause. The same thing semester, For example, if I teach one subject for a period of 1 year or 2 years, probably people able to retain the knowledge. That's the maybe true or no, I don't know, but that's one of the things. So speed is again the problem. In a paint shop, if I start moving the agitator at a slow speed, it will take more time for the mixing. And some depending upon whether there's a chemical reaction occurring or not, whether that is okay or not, that anything will come into the picture. So speed again comes to the picture. And same in data transmission, high-speed data transmission, some data can get lost because of the speed. So if you really look at the cause and effect, there is the speed and the loss of material. Loss of material is the effect, the cause is the speed. So what Hassler did, when you found out the contradictions, he found the pair of contradictions, something like he identified 13 pair of, I know he first found out that there are these pairs which are there, each pair has a typical solution which is being used. So he identified something like 39 by 39 matrix of the basically basic properties. He found out 39 basic properties, 39 by 39, and then he found out the combination of those to solve those contradictions. General principles which are used, something like 40 principles, they are commonly used irrespective of the field which is coming from. It may be electrical, it may be chemical, it may be mechanical or anything. The principles, but that doesn't mean you don't require the knowledge of the subject. You require the knowledge of the subject. Domain knowledge is required. However, the principles were something like a similar. And they studied something like 2,000, he studied 2 lakhs of patents. But today, for example, if you really look at it, they have studied, there's a data bank of around 25 lakhs patents they have studied, and they have made the richer and richer this matrix and all that. A lot of methodologies are available. Important is not that. If you really, there are many softwares also available on TRIZ. I don't believe in software to upper TRIZ because I have to also understand, only one thing I have to understand, I should study the cause and effect. And if any field, irrespective of the field, if the cause and effect is similar, then the principles of solving the problem may be similar. So I did not say, oh, that is electrical engineering, that is mechanical engineering. No need to say that. Find out whether cause and effect of similar nature, then principles use that you can actually. I want to tell you something. I really use this particular technique to solve some of my industrial problems, when I was in L&T. And my welding engineering, we did a lot of things. Basically, you might have heard about hot wire TIG welding, right? So what is the actually hot wire TIG welding? We use in order to identify the increase in the temperature, why that gives the better results. You use this particular methodology to develop the idea. Okay. So internet, lot of material is available, but basically understanding these principles is very good. I still today, for example, sometimes when I get time, I read this, I try to apply to some of the problems which I'm handling now. But basic principles should be understood. Forget about software part of it. Okay. Now, next is a value engineering. See, what is value engineering actually? The systematic method to improve the value of the product. We are saying value improving methods. And how can I improve the value? By function, by cost. So best thing is to examine the function. You examine the function and prepare the job plan for improving the pressure. There are something like 7 steps here I have mentioned there. Gather the information, analyze the function, generate the ideas, analyze the ideas, prepare the proposals, and present the proposals. So if you really look these 6 steps, they are involved 6 steps, and they are true just like what we talk about 7 steps in our design, making the plan for the purpose. There are 6 steps in the value, improving the value. And anything doesn't end unless we have the proper information. So I must have to gather the information. What are my objectives? What is that I want to do? Okay. And then, for example, look at the data, look at the function. In this function, what else can I do? Then analyze. That's why next step is analyzing the function. Then generate the ideas for each function and improve it. So processes are similar. So actually it doesn't make a difference. Basically, we have to understand the inner value engineering. So like what I said, tomato case. If you understand the function and the parameters which are involved to improve that parameters, either to reduce the cost or improve the functions, That's how value engineering works. There are a lot of value methodologies and things like that available. But important thing is to only to understand the principle, how to use it for our product development. Okay. So let us move a little further. At this now we are talking about innovation and things like that. So I want to give you an anecdote. Is it okay? I'll read the anecdote along with you. So you can also read on your screen, but I'll read it for you. A man was driving along a freeway when he noticed a chicken running along the side of his car. He was amazed to see the chicken keeping up with him because he was driving or doing 50 miles per hour. See the picture there? He accelerated to 60 and the chicken stayed next to him. He speeded up to 75 miles per hour and the chicken passed him up. Chicken was running actually in front of this car. The man noticed the chicken had 3 legs. So he followed the chicken down a road and ended up at farm. He got out of his car and saw that all the chickens had 3 legs. He asked the farmer, "What's up to the chickens?" The farmer said, "Well, everybody likes the chicken legs. I bred 3-legged bird. I am going to be a millionaire." The man asked him how they tasted. You know what farmer said? The farmer said, "I have not caught one yet. I yet to catch one yet." So lighter side apart, innovation has no end to it. You require to develop your ideas, keep a mind free, keep a purpose in mind, the innovation will occur. This may be a lighter side, but it gives you a lot of meaning to the what really innovation can be. Having seen that, let us go. I want to tell you something interesting. This is what I don't differentiate between the R&Ds, technology centers, and the academia as such. Because R&D institutes, they may be private, they may be R&D centers, or they are technology centers. What I did a few years back is I studied something like 22, but I was studying for my company and my particular division, which was a heavy engineering. So I studied something like 22 companies, what their R&D and technology centers all over the 22 companies, not only from India. There were few from India and most of the companies from abroad. And I actually made a lot of data collection of these companies, what their technology centers they do, what are the products, how they develop the products, what are their facilities available. And a very important thing why I want to tell you is the 5 important conclusions I have drawn from there. What those companies, the technology centers do. If you really look at these 5 things, it took me something like a study of 3 months to arrive at these 5 conclusions. The first one is development of products with the futuristic technologies for given functionality. Development of the products. See, today I have a product. How this product will look from, it will take what type of form 5 years down the line, and what is those technologies required for that. People start working on it for a given function. Like what I said, evolution occurs over a period of time, means changes, product form changes for a given functionality, and that's what they do. For example, today if you go and ask the GE, what the aero engines, what they are trying to look at, they are saying, how can I develop the engines 15 years down the line? In Bangalore, for example, one of my friends told me, they are looking like, for example, how to reduce the absolutely zero emission engine. What type of thing can happen? That type of thing they are looking for. So how the product will look down the line over a period of 5 years, 10 years, 15 years. And those they work on it. That's one of the things they work on it. The other thing they work on it is, how can I make the product multifunctional? See, for example, today you look at it, you might have seen we had a radio first, then we have 2-in-1, then 3-in-1. Even today, for example, we are holding in the hand, most of us are mobile. Today, mobile is a multifunctional. All cameras are gone, right? So people think that how can I make my product multifunctional? So that's another thing they work on. And third one they work on, efficiency improvement for existing products. The efficiency, I have put it in a apostrophe. You know why? Efficiency doesn't mean the output by input. Efficiency can be aid of operation, it can be small reduction in the cost, or aids in maintenance. It can be anything, but small efficiency improvement in the existing products. But these are actually done for the small, over a period of, I want to see 6 months, I want to get some market. So people do this type of study and they improve the product. Fourth one, what they do is, I have a product and they develop the related systems around the product. That's how things happens. And that's what, if you really see today, for example, the best example of this, somebody came up with a dryer for washing the clothes. First was a washer, right? Just washing the clothes. Then somebody said, no, I can also do the drying along with it, right? So actually you build a system. You first have the washing, then probably rinsing, and then drying of the clothes. So you combine the product into that, combine the functions into that. So related system has been developed to suit it. That's why previously, for example, if you see today, previously people had different compartments for it. Like first year, then you put it, remove this, and then put it in the drying compartment. Now you don't require to do that. You have only one product in which everything occurs, right? So think like that. Thinking is like that. So development is related systems around the products, and development in funda. Once you have these four things at the top, what we are just now talk about, if I want to do the work in that, then I must do some fundamental supporting technologies. That is materials, basic sciences, engineering analysis. Like today for engineering analysis itself is a vast field, and that's what we are going to talk in this program. But various analysis methods, for example. So parallelly, developing the product, you must also develop the necessary technologies to support the product development. And that's what all the companies do. I'm sure in academia, more or less, you work like this only. And this can become the guiding principle for development in the organization or the institutes. Okay. Now, at this stage, I want to tell you something important thing, like we talk about innovation and what other companies do and things like that, And I also made a lot of statements like you should do the innovation, you should think differently, and etc. etc. Just to give you an example, small thing to you, I was actually delivering the lecture in IIT to the young boys from the different colleges that had come there, and I was talking on my career actually. I was talking there. A lot of question and answers happened, and one boy asked me a question at the end. He said, "I want to ask you one question." There was actually a time shortage, but I allowed him to ask me that question. He asked me the question. He said, everyone tells us to think differently. Can you tell me, sir, how to think differently? I want to tell you. I got a little fumbled at that moment. But anytime you get a difficult question, what you say, it's a good question. So I said, it's a good question. Then I told him that it is a difficult to answer, and actually, this question is easy to answer and difficult to answer both ways. But I said, I'll try to answer you. The thing is like this. When you say think differently, you have to ask the question, why you want to think differently? This means I have some purpose and I want to better that purpose. And that's why I want to think differently. This means betterment of the purpose. I want to think differently. This means you define your purpose properly. You define your purpose very thinner and thinner. If you don't define your purpose thinner and thinner and thinner, you will not be able to think differently. Because if you think general purpose, you will get a general solution. But if you absolutely to the point, then you start thinking differently. And not only that is enough, making a thinner purpose, but you also require to put a criteria for betterment. If you don't put a criteria, for example, if I say I want to improve something by 10%, and then you say, no, I want to improve something by 100%. There's a difference, because when I want to improve something by 10%, maybe easy because solutions may be available. But I want to improve by 100%, I have to think I may not be able to use the generic solutions. Okay, that's one thing. And second thing I want to tell you is, sir, can I take 5 minutes more? Hello?
Yeah. Yes, sir, please. No problem.
Can I take 5 minutes more? Yeah. Second thing I want to just tell you, many people say you think out of box. What is the out of box? What is the box? Box is nothing but generic knowledge available to all of us is a box. And when I say I think out of the box, means this particular what you want is not available in this general box. So think something which is not there, which is new. That's what out of box is all about. Out of box means every out of box idea becomes generic over a period of time. For example, mobile came, for example, 20 years, 25 years back. That time it was out of the box idea. But today, is it an out of box idea? No. So every generic idea, every out of box idea becomes generic over a period of time. So we have to think really out of box is nothing but today generic idea is not available. I have to think little something new, which is we have to experiment. Okay. Having said this, let us go back to our product development cycle design thinking process, which we talk about 7 stages, right? Define, research, ideate, prototype, choose, implement, and learn. If you really see what has changed today, is it changed something today? Yes, something has changed. What has really changed? That's the reason I have put some 3 steps: ideate, prototype, and choose in a different color. For example, today computer-aided engineering is there to help us. And this has become, these 3 steps, really speaking, have become much more easier today as compared to what was in the past. If for example, I can generate the ideas, but I had a limitation on ideas, because how many ideas I will generate and then test them, prototype them? How can I do whether they will implement? How can I see that whether they will be implementable or not? Whereas today, life has become different. For example, 3D modeling, under CAE, I have listed here various factors. You read that. 3D modeling, multi-physics analysis and simulation for structural as well as fluid. For example, today, what we are going to talk in this program, FEA. What is that? FEA is all for all purpose. I'm able to do the analysis while developing things. I can simulate the things using the FEA. Even for example, computational fluid dynamics, CFD, using FEA. I can analyze the fluid problems. I can study the interaction between the structures and the fluid. All that is possible today using the finite methods, which you are going to have the discussion during this probably program in detail, right? Digital twin, then virtual reality, Internet of Things, artificial intelligence, rapid prototyping, and 3D printing. So many things are available to you today. And actually, that what it has helped you, because my ideation, I can generate various ideas, I can test them, I can check them using on a software. Prototyping is very easy. I can do the simulation of these things and I can choose the better idea. At least I can shortlist the few ideas and I can convert them into physical models, right? So this has really has given an impetus. That's why I written there at the bottom. CAE has opened immense opportunity for innovative and creative product development process by reducing development cost and time, both. Because see, for example, previously one model I have to make something, then it takes time. Today you can really sit on the software and you can develop the different models, develop different ideas, you can simulate it. And most important part of it is the virtual validation. Virtual validation. I need not do the physical validation. I can do the virtual validation at least to get a trend of it, understand the trend of that thing, and I can use it. So really speaking, this is the how things have changed today. And actually this has provided us impetus for the innovation to do better and better creative and innovative ideas. I can tell you, for example, this is actually just now today product development has opened really in a big way, because all these tools which are available to us can be used effectively in order to reduce the, not only reduce the cost, improve the faster process of developing the products. Okay. So I'm sure at the end of this program, where you are going to learn a lot of FEA analysis methods, etc., will enrich you to do this process effectively. Now, just to show you some of the, I collected a collage here of a different picture analysis thing. I'm not going to explain anything on this slide, but look at the different, something on a product development, something on analysis, something on a CFD, computational fluid dynamics, car models. Lot of pictures I have shown here, and this is how things are available to you. So somebody is sitting there and he's developing the product. You see on his table, you can see some of the parts lying, as well as he's making the computer model. So this is how things work today. At the bottom I can see some pictures which are actually simulation things being done. So this is just to give you an overall what is stored for all of us, right? Having said this, we'll conclude our talk, today's lecture by saying, learn from experience, start questioning, explore new means and innovate. Be a catalyst of evolution in India's growth journey. Atmanirbhar Bharat. This is our Prime Minister's slogan. I think we have to live up to that. So learn from experience. Experience means not from the experience only, from your own experience. Take the other people's experience. Do the research properly. Find out what has happened. Start everything you do. You should start questioning it. Questioning from the constructive way. Many times we question in order to show down. Please. Questioning is for the purpose or for exploration. Questioning for exploration should not have limit at all. And explore new means. That's what I said. Functionality. Product changes every day. Functionality remains the constant. What we have to develop is a new means. And new means, how can I achieve it? Be innovative. Be innovate something. And we have a chance actually, all of us, because today so many, as we said just now, so many techniques are available, so many facilities are available. Actually, we can become the catalyst for the evolution in India's growth journey. And there's a quote written there. If you really see a very interesting quote there, innovation is the ability to convert ideas into innovations. It says, what is the innovation for purpose? Innovation is if I don't develop the product which is marketable, which satisfies the need of the people, which doesn't improve the welfare of the man, there's no use. It has to give the money back. So innovation is the ability to convert ideas into invoices. I want to conclude last with the end note. I'll read it for you, end note. The trick to having a good ideas is not to sit around in a glorious isolation and try to think big thoughts. The trick is to get more parts on the table. Developing ideas is one thing, but start working on those ideas. Put it on the table. This means start working on those ideas, because otherwise it becomes only thinking, sitting in the air-conditioned office and thinking on the ideas, no use. Start working on them. Start making them realization. Then the things happen. And the last one is, to the optimist, the glass is half full. The pessimist, the glass is half empty. The engineer, the glass is twice as big as it needs to be. So I think this one, and thank you very much for the patient listening. It was one way, it's a monologue, but I hope I'm able to give you the message that please go on exploring, develop the new means, and make India richer and richer. Thank you very much.
Thank you, sir. Excellent time management. You asked for 5 more minutes, and it is 11:05 now.
Yeah, that's right. That's right.
Yes, sir, they say that, dear participants, they say that a table talk with a wise man is worth reading 10 books. On the basis of the on the basis of the vast experience that Professor Sadekar has, he has shared many different ideas very thoughtfully, clearly, and with lots of elaboration and their explanation. Sir, I must inform you that there are about 60-65 students who have been continuously, participants, I'm sorry, who have been continuously listening to you. This strength is twice as much the strength that we generally have when we conduct a physical course. Therefore,
I know.
Initially you said that your purpose of participating in the course was to reach out to as many people as possible across the country. Has been, very successful. I am extremely, grateful to you and thankful to you for sparing your time from your busy schedule, and also for highlighting the importance of finite element analysis and strengthening the purpose of conducting this FDA further. If you allow, can we take 1 or 2 questions more if anyone has any question?
No problem.
Okay, sir. Dear participants. Okay. Dear participants, if you have 1 or 2 quick questions, we can maybe take your questions and then close the session.
No problem at all. I have time.
I'm waiting. Let's see if anyone has any question.
Okay.
Okay, sir. It seems they have all understood the points very well, and since the contents can be communicated to you them later on, they can further read and strengthen their ideas. And
My
on
email is
behalf of,
there. There's no problem.
okay, okay, on behalf of my institute, on behalf of AICT, my institute and my department, and on my personal behalf, I thank you for your sparing time and sharing your valuable experience with us. Thank you very much.
Thank you, sir, for giving me this opportunity to be. I enjoyed the session. I hope all of you are enjoyed. Thank you very much.